All right, so class, welcome back. Today we're gonna go over example 5. In this example, we're still talking about position, velocity, and acceleration. This is in the section of higher order derivatives. And in this question, we are assuming that we have an object and we're given a position function by s of t, where t is measured in seconds. And we're gonna assume that the velocity at 20 seconds is going to be negative 15 meters per second, and the acceleration is assumed to be negative 35 meters per second square at 20 seconds, right? So the question is, after 20 seconds, is the object slowing down or speeding up? So they give us already information here, right? And what I want to direct your attention is the sign value. The sign value makes a lot of difference here. So an object, if you think about it, is traveling in a straight line. So if the object is traveling in this line and is moving in that direction, right, the velocity of this object, velocity, is going to be positive. And the acceleration is also going to be positive, right? Now it could be positive 3, and that means that it is moving in the right direction, to the right direction, but it's going very slow, right? Its acceleration or the rate of change is very slow. Versus if we're saying that the velocity of the object is negative, then that means that the object is moving in this direction, right? In that direction of negative. So it could still be it can still have a position that is positive, but it has a negative velocity, meaning its rate of change is going to the left side. The same argument is for acceleration. That means that is if an object is changing, if the acceleration is negative, you can still move to the right side. You can still move to the right side, but what's happening is that your rate of change of velocity is negative, meaning that this object is probably slowing down, right? So in other words, whenever your velocity is in one direction and your acceleration is in the other direction, then that means it is slowing down, right? Because now the acceleration means that it is gonna the rate of change of the velocity has changed, right? It's not moving in consistent with the velocity. It's moving in the opposite direction, so it's making it go slower. So here in this example, we have velocity is negative and acceleration is negative, so they're both going in the same direction, right? They're just both going in the negative direction. In this case, we're saying that it's going to be speeding up because they're both are consistent, right? They're both the same. So in this case, this will be the object is speeding up. And then if you want to think about it another way is if you have an object, right, is thrown up, right? If you throw it up, right, you're here and you're throwing it up right here. Here the ball, the rock is when it's going up, it has a positive velocity, right? Velocity is positive. Velocity is positive, but it has a negative acceleration. Why? Because the acceleration is used for from gravity, so it's negative 9.8, right? And so the acceleration is negative. So that means that the object is slowing down to the point that is velocity is 0, and then it starts going down, starts going down. So again, if both signs are the same, then that means it's speeding up. If the two signs are different, then that means it's slowing down. In the next example here, we have negative velocity and positive acceleration, and so that means that the velocity of the object is going in this direction, but it's slowing down because the acceleration is in the opposite direction. So that means this is slowing down. So particle is slowing down. All right. So I hope that you guys found this one helpful. Please let me know